What's up everyone, welcome back. Patrick here, moving on to the next question, still dealing with graphing factored form quadratics. So this is the second video in a series. I went through another video where we were graphing factored form quadratics. Hopefully you're watching this on the website and going through the videos in order, because there's going to be lots of carryover from the previous video to this one. I'm pretty much going to be following the same process. If you're watching this on YouTube, you can go to the course website where the videos are in order. There's a link in the description box. So in the previous video, we were graphing factored form quadratics, and same thing here. These are all going to be in factored form, but they're sort of unique formats. They're a little bit different, if you notice, than the previous video. So starting with part A, we got y equals x times x plus 4. Now, a factored form quadratic, as we've mentioned in previous videos, it takes the format like this, right? So for example, if we plug in some numbers, let's say we got an a value of 5, and let's say x minus 1, x plus 3, for example. Okay, that's the common case for a factored form quadratic. So where you're going to have full factors like this, you're going to have some kind of a value. And notice that this, it looks different than this, but this actually is in that format. Because what we can do in this case is this x by itself, we can actually rewrite it as x minus 0. And then we have x plus 4. Okay, you're never going to see this kind of format because x minus 0 would be weird to write. You just wouldn't write the 0. You'd have the x by itself. But I just kind of want to show you how this is factored form. It's like this. And so from here, you could tell that this x by itself, or x minus 0, which are the same thing, it's going to have an x-intercept of 0. Because remember, in this factored form, the x-intercepts are the m and the n, right? So x minus m is the x-intercept, well, x minus 0, that means for this factor here, the x-intercept is 0. So just in general, whenever you see a quadratic like this in this kind of format, notice that a and b are in the same formats. It's just here in a, we have an a value of 1. Over here in b, we have an a value of negative 3. But the format of these, in general, is like that. Okay, and whenever you see something like that, one of the x-intercepts is always going to equal 0. And if the x-intercept is 0, what does that mean on a graph? Well, it means that that's the x-intercept at the origin. And if there's an x-intercept at the origin, notice that that's the y-intercept as well. So the x-intercept and the y-intercept is 0 for any quadratic you see in this kind of format, and then it's going to have some kind of other x-intercept depending on what this factor is going to be. But just in general, this, they have an intercept at the origin. It's an x-intercept, and it's also the y-intercept that's going through 0. Okay, so just want to point that out, that whenever you see something like that, automatically you can know what you are dealing with. Now, if you want to algebraically show this, so now we're going to go back to the process that we were doing before. How do we find x-intercepts? Well, we plug in a value of 0 for y. And then what we do is we figure out what x values would give us a y value of 0. Well, as I just mentioned, an x value of 0 by itself would do that because the x is by itself here. So if we plug in 0 for this x, 0 for this x, we'll have 0 times 4, which gives us that y value of 0. And then the other x value that would give us a y value of 0 would be an x value of negative 4. So that's the other x-intercept in this case. So let's write out these characteristics here. So the x-intercepts are at 0 and 0 at the origin, and then at negative 4. and 0. All right, and now that we have the x-intercepts, the two x-intercepts, what's the next thing we could find? Following that same process from the previous video, we could find the axis of symmetry. Or the same thing as the axis of symmetry is the x value of the vertex. And what's the x value of the vertex going to be? It's always going to be in between the intercepts. So we could add the intercepts, 0 plus -4, and divided by 2. Okay, remember, m plus n divided by 2. So in this case, we'll have 0 plus -4 plus minus, that ends up being a minus, divided by 2. -4 divided by 2 would give us -2. So we have a vertex of an x value, at least, of the vertex at -2. That's the axis of symmetry. If we want to find the corresponding y value of the vertex, well, what we can do is just plug in that x value of -2 into the function like that. So we'd end up with -2. -2 plus 4 would give us +2. -2 times +2 would give us -4, like that. So the vertex in this case is happening at a y value of -4. So the coordinate, the full coordinate is -2, -4 for the vertex. Now in the previous video, I also got the y-intercept. Even though it doesn't state it in the question, it's an easy coordinate to get. You just plug in an x value of 0 and get the corresponding y value, and then it just gives you a little bit more detail in the graph. And as I mentioned also in the previous video, it's a nice way to check that your graph makes sense. But as I mentioned, the y-intercept in this case is the same as the x-intercept because it's going through the origin. So the y-intercept is just at 0 and 0 as well. So it's not a separate point, it's actually just the same point, right? And that happens for these kinds of quadratics over here when they're in this kind of format where the x is by itself. So we have enough characteristics to make a graph here. So let's go 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. So we have this point over here. We know it's going through the origin. We know the other x-intercept is -4 and 0. And then we have a vertex at -2 and -4, which would be down over here. Like that. And then we just connect these. This should be a little bit more like a U shape. But anyway. All right. So in this case, that ends up being the parabola. Okay, so a quadratic in this format is always going to go through this. And I think I've mentioned this in previous sections as well. But it's always going to go through this. So sometimes you'll have the x-intercept here. This could also be a graph where maybe it's flipped over, or maybe you'll have another x-intercept here. I think that's going to happen over here where it's going to be a positive x-intercept, except the a value is going to be negative. So actually it's going to look something like that. So this kind of quadratic, it's always going through that origin. So just remember that. As soon as you see that, you can automatically just know what you are dealing with. All right, so let's move on to part B. Now, part B in this case, notice we have an a value of -3, but that doesn't affect the x-intercepts. I mentioned that in the previous video as well. The x-intercept we're always just getting from the factors. So the first x-intercept is 0 and 0. Actually, let's label this. So we got 0 and 0. And then also, when does x minus 5 equal 0? That's happening at an x value of +5. So we'll have 5 and 0. That's the other x-intercept. And then from here, we have the two intercepts now. We can find what the x value of the vertex is, or the axis of symmetry. Both of those mean the same thing. And how do we do that? Well, we add up the x-intercepts, right? The x values of the x-intercepts, we add up this 0 and then this 5, and then we divide it by 2. So in this case, we're actually going to get a fraction, which would be 5/2. You could also work with decimals if you want, 2.5. I'm going to work with fractions. I feel like they're tougher to deal with. So just in case your teacher does require you to label points and fractions, that's what I'll show you in this video. But if you want to use decimals, feel free to as well. So the vertex, we know the x value is going to be 5/2. And so what we have to now do is find out the corresponding y value. Well, we could plug in this 5/2 for the actual equation to get the corresponding y value. So we'll have -3 times 5/2, and then we'll have 5/2 minus 5, like that. So from here, let's work with this bracket first. So we'll have 5/2 minus 5/1. We can multiply this by 2, multiply this by 2, 5/2 minus 10/2, which would give us -5/2. That makes sense. 2.5 minus 5 gives us -2.5. So this bracket would be -5/2 like that. And then this -3 is like over 1. We can multiply all the numerators, multiply all the denominators. So we'd get, what, 75 up top, positive 75, right? -3 times 5 is -15. -15 times -5 would give us positive 75. And then 1 times 2 times 2 would give us 4. Right, so the vertex, the y value of the vertex in this case is going to be 75/4, like that. Now, even though we'll label the vertex in fractions, I mentioned this in the previous video as well, I actually recommend getting the decimal values of this when you're graphing it, because I feel like with decimals, it's easier to see where it's going to be on the graph, right? This 18.75, this y value, we know that it's going to be between a y value of 18 and 19, closer to that 19 value because of the 0.75. Versus here with 75/4, okay, you could do the mental algebra and stuff, but it's kind of just tougher to see where this is going to be on the graph. This one's not bad because it's a simple fraction, 5/2. But even this x value can sometimes get a little bit more complex. All right, so if your teacher does require you to label it, there's a fraction, but I do recommend converting it to a decimal on the side when you are graphing, because it's just easier to see what goes where. So let's start off with the intercepts. So we got 0 and 0. And actually, this is going to be opening down. So let me adjust this graph here, just because I have limited space to work. Actually, we can just keep it like that. So one of the intercepts, 0 and 0, right, the origin. Then we have the other intercept, which is at 5 and 0, right there. And then 18.75, let's maybe go up by, let's go up by 5. So we'll have 5, 10, 15, 20. Okay, if you're using graph paper, you can maybe go up by 2s or 1s. Just to save room here, I'm just going to go up by 5s over here. And so the x value of the vertex is happening in between these at 2.5. So that's like right there. And then 18.75 or 75/4, that's going to be like up here, right? So this vertex is 5/2, 75/4, like that. And it's opening down, right? And that makes sense because the a value is negative. And so just connecting these points here, we'll have that going through there, and then that going through there. These are not always the best drawings on my part. Once you have graph paper, you can make a nice symmetrical one. All right, but that there ends up being this quadratic here. The axis of symmetry is happening at this x value of 2.5 or 5/2. So now moving on to part C, we got y equals x plus 4 to the power 2. So notice this is another unique format. This format here in part D is actually the same. And in general, this kind of format, what makes it unique is this is actually in both factored form and vertex form. So factored form, just to bring it back, is like this. And then vertex form is like that. Okay, when we dealt with vertex form, we went through parabolas in this kind of format. Well, notice that this x plus 4 squared, what that means is that there's just 2x plus 4 factors like that. And so it's in factored form, right? There's 2 factors, and then the a value in this case is 1, versus here the a value is going to be -3. If there's nothing here, sometimes you'll see even a negative there. That means there's a -1 in front. Okay, in this case there's nothing there, so it's just a +1 for the a value. But the x plus 4 to the power 2, we can rewrite it as x plus 4 times x plus 4. So notice that it's in this format. So we got x plus 4 times x plus 4. But also notice that it's actually in this vertex format as well. It's just the k value at the end is 0. Okay, so here, if we rewrite this, we'll have 1x plus 4 squared plus 0, like that. Okay, so we could take this, y equals x plus 4 to the power 2, and we can think of it in factored form, or think of it also in vertex form. Same thing with this one over here. That's what makes these unique. And if you remember in the vertex form videos, whenever you have something like this in this kind of format, just in general a vertex form, the vertex is going to be at h and k. So from the vertex form here, we could tell the vertex is going to be at -4 and 0. But also notice from these factors that the x-intercept is -4 and 0, right? And there's like 2 of them over here. Right? Remember, the x-intercept is always going to be the opposite sign, the m and the n, but in this case, both of these give us an x-intercept of -4. So just in general, if you get a quadratic like this, where you got like x minus, let's just keep it like this, okay, the vertex is actually equal to the x-intercept. The vertex and the x-intercept, notice there's only one x-intercept. They're both the same thing, okay? And it's happening at an h value of 0. Okay, if you're working with factor form, if you want to put an m here, you could put that as well, and then you'll have m and 0. Doesn't really matter what letter here you put, but anything in this kind of format, okay, the vertex and the x-intercept is always going to be the same, and there's only going to be one x-intercept. So it makes it fairly easy to deal with, because notice we don't have to find the x-intercepts or the vertex, because they're equal, they're the same thing. It's just happening at -4 and 0. So if we graph this out, we'll have -4 and 0, and then notice that the a value is +1, so we know it's going to be opening up. So the x-intercept and the vertex are the same. And if we want to get another coordinate, what we can actually do is we can get the y-intercept in this case. So what we can do is we could plug in 0 for x, and we'd get a y-intercept of 16. So we'd have 0 and 16. If we just want another point for reference, another thing you can do, if you want to, is you can make a table of values and put that vertex in the middle, like that. See, the problem with this is that we only have one point to deal with, right? And whenever we had like full factors and these were different, we were able to get 2 x-intercepts. We were also able to get the vertex, which gave us 3 points to make a nice graph. Well, in these kinds of formats, the vertex and the x-intercept are the same. There's only one x-intercept, so we only have 1 point for reference. So you can make a table of values here where you maybe like use a couple of x values to the left and to the right, get the corresponding y values to make a symmetrical table, right? We went through making a table like that for vertex form. But I think this is enough. You just can get another point, and an easy point to get is the y-intercept. It's going to be at 0 and 16. And then if they want another point, if they want 2 other points, well, you can just sort of, if you want, you know that this has to be symmetrical. So notice this is going to come up over here. And so notice what's the distance from this point, from the intercept to this x value of 0. Well, notice it's 4. So if we put another distance of 4 here, we'll get to an x value of -18. That means that the y value has to be the same. So another point would be -8 and 16. And then you can also confirm this. You could take this x value of -8, you could plug it in here. You'll have -8 plus 4, which gives us -4 to the power 2, would give us positive 16. Right, so different ways you can get other points. But just in general, something like this, in this format, the vertex and the x-intercept are the same, and it's just going to be hn 0. The vertex is going to be on the x-axis. Sometimes it could be opening down, so notice in part D, that's what's going to happen. So let's erase all of this. Let's work with part D. So with part D, the x-intercept and the vertex are the same, right? Notice we only have one factor here, and it's squared. And so the x-intercept and the vertex, they're happening at 2 and 0, right? It's always going to be the opposite sign, x minus h, x minus 2. H and 0, 2 and 0. Okay, so the x-intercept and the vertex is at 2 and 0. And to get another point, let's get the y-intercept, so we could plug in 0 for x, -3, -2 to the power 2. So we'll have -3, -2 to the power 2 is 4, -12. Okay, so the y-intercept is at 0 and -12. And I feel like that's enough to make a graph. So 2 and 0 over here, that's the x-intercept and the vertex. And then we have a y-intercept at 0, -12, which would be like down here. And it makes sense that it would be down here because we have a -a value, so the parabola is opening downwards in this case. Okay, and again, if you want to make a table of values, if your teacher requires a table of values for the other points, they want a little bit more detail, well, you can always put the vertex in the middle, pick 2 x values to the left, so that would be 1 and 0, 2 x values to the right, take these, plug them in here, right? So if we plug in 0, we know we're going to get -12. We plug in 1, 1 minus 2 is -1 to the power 2 is +1 times -3 would give us -3. 3 minus 2, 1 to the power 2, 1 times -3. Then 4 minus 2 is 2 to the power 2, 4 times -3 gives us -12. So you'd get something nice and symmetrical, right? So you can also do a more detailed table of values and then plot all these points and then plot the graph. Okay, so as a quick review, if something's in this format, the vertex and the x-intercept, they're the same. They're happening at h and 0. They're happening on the x-axis. And then if you get a quadratic in this kind of format, okay, one of the x-intercepts is always going to be 0. And it's going to be the y-intercept as well. It's going to be going through the origin. All right, so be on the lookout for this kind of format and that kind of format.